Hi, everyone. Okay, let's look at how to calculate the factorial of a number using recursion by writing a Python function. Okay, so here is the function definition. I called it factorial, and it's going to take one parameter, n. Okay, so what is factorial of a number? We're only looking at positive numbers, so you don't have to validate if n is positive. You're going to assume that. So we're going to calculate the factorial of a number, and the factorial of a number is the sum of multiplication of all the integers smaller than that positive number. So what does that mean? If we're calculating factorial of 5, it's simply 5 times 4 times 3 times 2 times 1, okay, which equals 120. If you're calculating factorial of 10, you would go all the way from 10 times, 9 times, 8 times, so on and so forth, till 1. Remember, factorial of 0 is 1, and factorial of 1, of course, is just 1, okay? Now, when we look at factorial, you could, of course, do it using iteration, but in this example, I want to show you how to do it using recursion, and we're going to use our 5 steps that we talked about in the first intro video. So the first step was to determine the parameters, right, for the base case or the recursive case. In this case, I've kind of given you the parameter. It is n, and n is the number that you are calculating the factorial for. Now, what is the base case? The base case is when you don't have to call the function again. So the base case would be 0. In this case, because the factorial of 0 is 1, and this is the condition that stops the recursion. When n becomes 0, the function just simply returns 1 and does not call itself anymore. Okay, so we've found the parameter, it's n. We've determined the base case, which is n equals 0. Now we need to determine the set of subproblems, or the recursive case, right? In this case, if you look at calculating factorial 5, it's nothing but 5 times factorial 4. Similarly, factorial 4 is nothing but 4 times factorial 3. Factorial 3 is 3 times factorial 2. Factorial 2 is 2 times factorial 1. And factorial 1 is actually 1 times factorial 0, which we know is our base case, and that's 1. So factorial 1 is 1. Okay, so we've determined that the subproblem is calculating the factorial of n minus 1. And this is the recursive case where the function calls itself, but with a smaller value of n. So every time we call the function, we decrease the value of n by 1. So we're going to call the function factorial with n minus 1 in our recursive case. Now, step 4 was we need a loop to check the current value. So we're just going to use if n equals 0, because we determined that's our base case. And step 5 would be to process the subproblem and combine the results. In this case, it's just the result would be n times factorial n minus 1. That would be the result that we're returning. Does that make sense to you? Okay, I'm going to give you a minute now to try with these 5 steps in mind to write the factorial function. You can, of course, pause my video and go ahead and try to write the function. Okay? Okay, let's try it now. So we determined that our condition is if n equals 0. And now we need to return our base case. And our base case is simply going to return 1. And if not, what do we want to return? We want to return n times factorial n minus 1. Now, let's try to call this function. You can, of course, also have an else here, but there is no need for it because we're anyways returning. So let me try to call the function from outside. we determined that factorial 5 was 120. So I'm going to actually call it for factorial 5. Let's print the output so we can see it. And let me run the code. And you'll notice that it returned 120. Okay. Go back to this, look at the 5 steps and make sure that you're able to understand how we got to this code. Okay. All right, I will do another example for you shortly.